Channel. I am Dr. KP Naidu. In this lecture, I am going to discuss about how to evaluate the performance of regression model. Clear? So, to evaluate the performance of any regression algorithm, we are using different metrics. Based upon that matrix, we are evaluating the performance of different machine learning regression algorithms. For example, we are already discussed some regression algorithms. Linear regression is one type of regression algorithm. Maybe KNN regression is one type of regression algorithm. And the decision trees are also used for solving the regression problems. That is called a decision tree regressor is also used for solving the regression problems. Likewise, we may build different regression models to the given dataset. To evaluate the performance of those regression model, we are using different metrics. Those metrics are first one is mean absolute error, that is MAE. Okay, that is one metric we are using. Another one is MSC, that is called as mean squared error is another metric to evaluate the regression model. The third one is RMSE is another metric to evaluate the regression model. And another one is R square score. This is also another metric to evaluate the regression model. These are the main four metrics we are using to evaluate any regression model. Okay, so before understanding how we are applying these equations to any model, let us say one example of regression model. This is the data set. We already discussed about this data set in linear regression problem. Okay, so if you are not understanding this uh, regression problem, in the below description I provide the link how to solve this problem using linear regression. Just go through that link. Okay, so to this data set we are building a linear regression equation. Okay, that is y cap equal to 0.66 plus 1.43x. This is the equation we are obtained to this given data set by using the linear regression equation. How we are getting this equation? In the below description I am providing the link. Just go through that link. For example, in this we are having the independent variable is x, dependent variable is y. The independent variable x, okay, these are called as the actual values. These are called as the actual values of independent variable, and these are the actual values of class label. Actual values of which one? Class labels. For example, if we can take the value equal to x equal to 2. So now if x equal to 2, what is the actual output? 4. If x equal to 2, the actual output is how much? 4. Clear? So now if you substitute x equal to 2 in this equation, we are getting some value. That value we are called as the predicted value. For example, if you're substituting x equal to in this equation 1.43 into 2, we are getting it is equals to 2.86. So that is added to which one? 0.66. So if you add 0.66 plus 2.86, we are getting 25, that is 3.52 something. This 3.52 is the predicted value by the model. That means to this data set we are building the model. To that model we are providing some test value x equal to 2. If you substitute x equal to 2 to this model, we are getting the value is 3.52. This value is called as predicted value. The difference between what is the actual value to x equal to 2? 4. The 4 minus the what is predicted value? 3.52. The 4 minus 3.52 is equals to 0.8. This 0.8 is called as the error. 0.8 is called as which one? Error. That means The error, the simple error means the difference between the actual value minus the predicted value. To find out the error of the entire model. Okay, so now for that we are using the one metric is called as mean absolute error. Mean absolute error values of the model 10, 20, 30. The predictions are 12, 18, 29. So if you want to find out the mean absolute error, okay, so sigma I equal to 1 to n. Here n is the number of observations. N is the number of observations. Here how we have how many observations? 3. That means n equal to 3. Okay. So yi means what is the actual value. Okay. Ya cap means what is the predicted value of that model. The actual value of that model, if the actual value of that model is 10, the predicted value is 12. 10 minus 12 plus 20 minus 18 plus 30 minus 29 by number of observations 3. That is 2 plus 2 plus 1 by 3. We are getting is 1.67. So 1.67 is the mean absolute error to the given actual values. Okay. Likewise, we are finding okay the mean absolute error to the any model. Okay, for understanding purpose here I am taking the small values for data set. Okay, only three values for actual values and three values for which one predictions. From this we are getting which one mean absolute error. So what the mean absolute error calculates, it gives the average absolute difference between the predicted value and actual value. The difference between the actual value and the predicted value absolute difference, that will be average. We are getting the mean absolute error. Okay, so that is the first metric to evaluate the performance of the model. So that means this is called as one mean absolute error. When we say the model is good, so if this value is low, less, then we can say that that model is the best. If this value is more, then we say that the model is not a good. Okay, based upon this value, we are evaluating the model. And another metric is mean squared error. Mean squared error is the another metric to evaluate the model. Okay, so simple as like mean absolute error. Okay, the MSC what measures means the average, simply the average of which one, the square difference between the predicted and actual values is the MSC, mean squared error. Squaring emphasizes the which one, larger errors, which can be helpful if you want to penalizing the big mistakes. Okay, so mainly if you want to penalize the big mistakes, we are using this mean squared error. The mean squared error means we have to square the difference between actual value and predicted value, then we have to average that squared error. Okay, so let us assume for any model the actual values are 10, 20, 30. Okay, and the predictions of that model may be a 12, 18, 29. Okay, so similar way we have to actual value is 10 minus 12 whole square plus 20 minus 18 whole square plus 30 minus 29 whole square by number of observations 3, that equal to 3.0 is the mean squared error. Clear? So this is also one metric to evaluate the regression model, regression algorithm. If this error is low, then we say that that model is good, or else that model may not be a good model. Okay, so another metric to evaluate the regression algorithm is root mean squared error. Okay, we already know that MSE value, mean squared error. Okay, if we are performing the root of that MSE, we are getting the root mean squared error. In the previous metric, we are getting the mean squared error is 3.0. If we are performing root to this 3.0, we are getting approximately 1.73. That is the root mean squared error. Okay, so RMSE is the square root of which one? MSE, which brings the error back to the same unit as the which one? Target variable. Clear? So it is also error. That's why we are trying to build a model that model having as much as less this error value. Clear? That is about RMSE. Clear? And another most important metric to evaluate the regression algorithm is R squared, or it can represented as R square. Okay, so it is little bit different than compared to the previous three metrics. Okay, the previous three metrics we can mainly focusing on the error, but in this what the R square represents means it is a proportion of variance in the dependent variable that is predictable from the independent variable. Okay, the R square value its value is in the range from 0 to 1. Its value is from 0 to 1. Okay, so the value, the formula for R square is 1 minus sigma I equal to 1 to n ya minus y bar whole square by sigma I equal to 1 ya minus y bar. Here y bar is the mean. Okay, the mean of the total observations. Okay, so now this yi minus y bar whole square we can also called as okay total sum of the squares, that is called as next yi minus y bar whole square you can also call as residual sum of the square. That means we are simplify this one is 1 minus rss by tss is also one another, like we can also write equation like this 1 minus residual sum of the squares by total sum of the squares is also the equation for which one r square. Okay, so now how to calculate this r square value means that is these are actual values. Okay, the mean of this 10 20 30 10 plus 20 plus 30 by 3 60 60 by 3 its mean is how much 20, and if that model predictions value, let us assume 12, 18, 29. So how we are calculating residual sum of squares? 10 minus 12 whole square. That means actual value minus predicted value whole square plus 20 minus 18 whole square plus 30 minus 29 whole square. Its value is 9. And total sum of square, that means actual value minus mean value. That means 10 minus 20 whole square, 20 minus 20 whole square, 30 minus 20 whole square, its value is 200. So 1 minus 9 by 200, it is value is 0.955. That means the value of r square is in between 0 to 1. Okay, so when we say that that model is good, if this value is nearer to 1, then we say that that model is good. Why? Because simply we can see this equation 1 minus we are trying to subtracting with some error value. Okay, so 1 minus some error value means if you get in the big value, then only that we say that that model is a good model. If the value is low, that model is not a good model. That means if the r square value is more, then we say that that model is a good model. If the r square value is low, then we say that that model is not a good model. And r square value is in between 0 to 1 only. Okay, if you want to converting into percentage, then it can be multiplied with some 100, then we getting the percentage. Okay, that is about the r square metric. So another metric to evaluate the regression algorithm in mean absolute percentage error. Mean absolute percentage error. Okay, so the formula for mean absolute percentage error is 100 percentage by n, n is the number of observations, sigma I equal to 1, ya minus y cap by what's called as the actual value. Clear? So actual values are 10, 20, 30. Okay, if you are applying the some instances to the model, let us assume we are getting the predicted values are 12, 18, 29. Okay, if substituting these in this equation, okay, 100% by number of observations are 3. Okay, 10 minus 12 by 10, 20 minus 18 by 10, 30 minus 29 by 30. We are getting the values 11.1%. So this is mean absolute percentage error. If the percentage is low, that means that model may be a good model. If the percentage is more, then model is not a good model. So what mean absolute percentage error represents? The average percent error. The average percentage error between actual values and predicted values. That is called as the mean absolute percentage error. So these are the five metrics we are using to evaluate the performance of the any regression algorithm. So by considering these matrix values only, we say that the particular model is the best. Okay, that is about the performance evaluation, sorry, evaluation matrix of a regression model.